Hey everyone, welcome to a brand new deep dive. Today we're tackling software design patterns, specifically the observer pattern. We're going to break down how it works, why it's so cool, and how it plays out in real-world code. So, imagine a bunch of objects all waiting for the latest update from one specific source. Think like a message board new post. Boom, everyone subscribed gets a notification.
Yeah.
That's the observer pattern in action.
You got it. The observer pattern is this cool principle where one object, we call it the subject, keeps a list of its followers, the observers. When something changes with the subject new message on the board, for example, it automatically tells all its observers, hey, something's new, go check it out.
Like a chain reaction, but in code.
Exactly. And the real beauty of this pattern is its elegance, especially when it comes to decoupling. The subject, our message board in this case, doesn't need to know who those observers are or how they'll react to the update. It just does its thing, and they do theirs. This separation is key for flexibility. You can change one part without messing up the whole system.
Right, so no more rewriting tons of code just because you tweaked one little thing. So how does the observer pattern make our code, as they say, future-proof?
That's where extensibility comes in. We're talking about making it super easy to grow your code without headaches. With the observer pattern, adding new observers is a piece of cake. You don't even touch the subject's code, so less risk of bugs.
Okay, so it's flexible, adaptable, but what about efficiency? Does this elegance also save developers time?
Absolutely. Think of reusable code like Lego blocks-y rebuild when you can just use the blocks you already have. The observer pattern lets you reuse both observer and subject components in tons of scenarios, saving you precious coding hours.
Love that. Working smarter, not harder. Okay, enough theory. Let's see this in action. Slide 5 shows a temperature monitoring system. Say we've got a temperature sensor. What kind of observers might care about its readings in, let's say, a smart home?
In a smart home, that sensor could be the boss. Think about it. A thermostat adjusting the heat based on those readings, or digital displays showing the temperature in different rooms. Each of these is an observer, reacting to every little change from the sensor, our subject.
So the sensor's talking, these devices are listening and reacting. Very cool. Now let's peek at slide 6, a code snippet. What's going on behind the scenes here?
This code snippet gives you a simplified look at how the observer pattern works its magic. You'll see the sensor has a function called notify observers. That's the heart of it all. When the temperature changes, this function is called, it loops through each connected device, thermostat, displays, you name it, and tells them, hey, update yourself.
So each device is on its own notification list, and the sensor's the messenger.
That's a great way to put it. And that's what's so cool about the observer pattern is make sure everything's on the same page, responding to changes without being overly dependent on each other.
So in our smart home, if the living room sensor suddenly gets chilly, it'll instantly tell the thermostat, which then cranks up the heat. But it's not just the thermostat, right? Those digital displays we talked about, they get the memo too and update their readings.
Exactly. It's like a perfectly synchronized dance, all thanks to this one elegant pattern.
Speaking of synchronized actions, let's jump to another example you use daily, your phone's messaging app. It uses the observer pattern to make those notifications pop up and grab your attention. Slide 7 sets the scene picture, a new message popping up in your inbox. How does the observer pattern make sure you don't miss that text?
It's like the messaging app shouts out, hey, something new just came in, every time you get a message.
So the messaging app is our subject, and the new message is what kicks off the whole shebang.
You got it. And your phone has a bunch of ways to let you know about it, right? Sounds, vibrations, those little banners on your screen. Those are all observers, kind of like the thermostat and displays in that smart home example.
Okay, so different flavors of notifications, all triggered by that one new message. How does the observer pattern actually make that happen in the code itself? Like, what's going on under the hood?
Let's jump to slides 8 and 9 for a sneak peek. Each notification type, the sound, the buzz, the visual, each one is its own separate observer class.
Like little notification squads all ready to jump into action.
Exactly. And that keeps the code nice and organized, easy to manage. Say a developer wants to add a fancy new notification type later on, they can just slide it right in without messing with the stuff that already works.
Nobody wants to break a system that's already humming along, right?
You said it. It's all about keeping things modular, adaptable. That modularity is one of the things that makes the observer pattern so powerful. You get flexibility without sacrificing efficiency.
We've seen how powerful it is, but like any tool, I guess it's not always the perfect fit.
Yeah.
We talked about decoupling earlier sometimes. Going for that separation can be overkill, especially if things are pretty straightforward.
You're totally right. It's like using a chainsaw to cut butter. Sometimes a simpler way is better. Too much observer pattern can lead to observer overload, where the system gets swamped with notifications and updates.
So it's a balancing act, using the right tool for the job, knowing when to keep things simple.
Exactly. It's about finding that sweet spot where the observer pattern shines without adding unnecessary complexity.
This might seem basic, but are there other design patterns that achieve something similar? Or is the observer pattern one of a kind?
Great question. It's like asking if there's only one way to bake a cake. In software design, you often have choices when it comes to solving a problem. One alternative is the publish-subscribe pattern, or pub-sub for short.
Okay, so how does pub-sub compare to the observer pattern? They both sound kind of similar.
They both deal with communication, but there's a subtle difference. Imagine a radio station, it doesn't know who's listening, but anyone tuned in gets the broadcast.
So the observer pattern is like direct messaging. Pub-sub is more like tuning into a specific channel.
Perfect analogy. In publish-subscribe, senders, the publishers, just put messages out on specific topics. Any interested parties, the subscribers, can tune in to those topics to get updates. Like subscribing to your favorite channels on a podcast app, you only get notified about new stuff you like.
Both patterns send and receive updates, but they go about it in slightly different ways.
Exactly. The best one to use depends on what you're trying to solve. Sometimes you might even use both together for an extra elegant and efficient system.
Makes sense, having different tools and knowing when to use each one. But let's get back to the observer pattern. We've talked about the concept, the advantages, even looked at some code. But how does this actually affect the user? What does it mean for someone who uses software every day, even if they're not a programmer?
Now you're talking. At the end of the day, it's all about the people using the software. The observer pattern might be behind the scenes, but it plays a big part in making your digital life smoother, faster, more responsive.
So when I'm scrolling through social media or getting those live sports updates, that's the observer pattern making things happen.
You got it. All those seamless experiences, those it just works moments, that's often the observer pattern humming away in the background. And because it helps create clean, efficient code, it usually means a happier user experience.
Because nobody wants to wait forever for an app to load or an update to show up.
Exactly. And as software keeps evolving, getting even more interconnected and responsive, patterns like the observer are going to be even more important.
That's super cool. Before we get too futuristic, though, let's loop back to something we touched on earlier. The practical stuff, implementing the observer pattern. Any tips for developers who want to use this in their own projects?
Definitely. One thing I always stress is keeping those observer classes laser-focused. Remember the notifications in our messaging app. Each type was its own observer, each with a specific job to do.
Right, so the sound notification only played a sound. It wasn't trying to also show a visual.
Exactly. That separation of concerns is key for writing code that's clean and easy to work with. It might be tempting to lump things together, but that can cause confusion and headaches later on.
A place for everything and everything in its place.
Love it. So true. And while we're on the topic of keeping things tidy, another tip is to make those observer classes lightweight. They shouldn't be bogged down with extra logic or tasks. Think of them as specialists. They get a notification and take a specific, targeted action.
Sounds like efficiency is the name of the game.
Yeah.
Keep it lean and mean.
You got it. And that efficiency means a better experience for both the developers and the people using the software.
Well said. We've explored a lot today in the world of the observer pattern. Its core ideas, its strengths, even how it works in code. But before we wrap up, one final thought-provoking question for you and our listeners. How do you see the observer pattern evolving as software development moves forward? Any exciting possibilities on the horizon?
Now that's a question that gets the imagination going. We're moving towards a world with even more connected devices and systems. The observer pattern, with its ability to handle communication and updates so smoothly, it's going to be crucial, even in ways we might not realize yet. Imagine a world where your smart home knows what you need before you do, or your car navigates traffic seamlessly. Those might sound like sci-fi, but they're closer than we think, and I think the observer pattern will be a big part in making them a reality.
I can't wait to see how it all plays out. A big thank you to you and to everyone listening for joining us on this deep dive into the observer pattern. Until next time.